Alright, welcome to the video tutorial for the rainbow balancing method. This is for our visual learners who are struggling a little bit with balancing. So this is something that Miss Hansen started last year, where she realized sometimes students who struggle with math or just are more visual learners really are more successful when they use colors on this. So you're going to need different colors of highlighters, and we're going to start on number 3. First thing we always need to do is divide our reactants from our products, because what we're trying to do is make sure they're equal on both sides. And then we're going to color code each element a different color. So I'm just going to randomly pick that green is going to be chlorine. So I'm going to highlight all of the chlorines that I see. And I'll say yellow will be my K, my potassium. I'll go ahead and highlight here as well. And then we'll use pink for iodine. Go ahead and highlight there. Okay, so now I have a little bit more visual representation instead of mathematical of my greens have to be equal on both sides, my yellows have to be equal, my pinks have to be equal. So in this case, looking at my greens first, I have 2 greens on this side. I only have 1 green there. So in order to get more, and I'm going to do this in pencil because sometimes we have to undo our work. In order to get more, I'm going to go ahead and put a 2 coefficient out front. That's the only thing we're allowed to change, are our coefficients. When I put a coefficient in front of a compound, it applies to everything though. So now I do have 2 chlorines, but just to remind yourself, that also changed your potassiums. Now you have 2 potassiums. Okay. So my greens are both happy. I've got 2 greens on both sides. If we look at yellows, I've got 1 yellow on the front, and I've got 2 yellows on the back on the product side. So I'm going to go ahead and in order to make the front one a 2, I put a 2 in front of this compound, and that gives me 2 yellows. It also gives me 2 pinks though. That's an unintended consequence. So 2 greens, 2 yellows. Now I look at my pinks, I have 2 times 1 iodine and 2 iodines already. So now it's balanced. I can go back through and add 1s in my blanks. That's all we need to do for that. We balanced it with colors instead of with math. Now looking at this, I have 1 compound, potassium iodide, and 1 compound, potassium chloride, and then I have singles, so a chlorine and an iodine. So the chlorine is replacing the iodine. We're going to call that a single replacement reaction like this. Let's go ahead and move down to number 4. Number 4 looks a little bit more intimidating, so be careful and watch how we color it. I'm going to start with blue this time. So I'm going to make my calciums blue. I've got a calcium there. I also have calcium here, so blue on each side. I'm going to divide my reactants from my products. I'm going to go ahead and make hydroxide my yellow. So I'm going to make sure that I highlight the entire OH in parentheses and the 2, because that 2 only goes to the yellow now. And then on this side, I have 3 of my yellows. Okay, if I grab the green, aluminum, I'll make green, making sure I put that 2 in the green because that's for aluminum. So I have 2 greens on this side and 1 green on that side. And then sulfate, SO4. I have 3 SO4s on that side and just 1 SO4 on this side, 1 pink. Okay, so I'm just going to go in order of my colors. Okay, I've got 1 blue and 1 blue, so I don't have to change anything. And when I look at my yellows, I have 2 yellows on this side and 3 yellows on this side. So in order to make them equal to each other, we have to find the common factor, which the easiest way to do that is usually just multiplying them together. Okay, 2 times 3 is 6. That'd be their least common factor. So I can't make this 2 a 3, but I can make it a 6 if I go like that. Now I have 3 times 2, 6 hydroxide here, and I also have just 3 there. But if I put a 2 coefficient, now I have 2 times 3, 6 yellows. So I've got 3 times 2 yellows and 2 times 3 yellows. So 6 yellows of each side. Okay. However, that unbalanced my calciums, right? My blues were balanced before, now they're not anymore, because now I have 3 blues on this side. So I have to come back and say, sorry blue, I'll fix ya. Put a 3 here, and now that gives me 3 blues on this side as well. So it is kind of balance, unbalance, rebalance sometimes. But 3 blues on both sides, 6 yellows on both sides. If I come over here and I look at aluminums, I have 2 greens on this side, and I have 2 greens on that side already. So my greens are balanced. I have 3 pinks on this side, and I have 3 times 1 pink there, so 3 pinks on that side, which means we did it. We balanced it. So I can put a 1 in my blank. Now what's really kind of helpful with this rainbow method is anytime you use 4 different colors, blue, yellow, green, and pink, it has to be a double replacement reaction. Okay, because I have two sets of compounds, no one is single. So I know that's a double replacement reaction. Looking at this last one, we're going to divide our reactants from our products again, and then we'll grab some colors. I'm going to make my carbons green this time, so I'm going to have, yellow. Wow. I'm going to have 3 yellows on this side, and just 1 yellow on my product side. And then I have 8 hydrogens, or 8 blues on this side, and 2 blues on that side. Let me make sure I get that 2 in the blue area, so I remember that's where it goes. Okay, and then I've got 2 pinks on this side, and 2 pinks on that side, but this is also a pink. So sometimes rainbow balancing is really helpful for combustion reactions, because I have oxygen in 2 different places in my product, which makes it a huge pain to do that. Okay, so we're just going to start from the beginning again. Look at the first color. My first color, I have 3 yellows and 1 yellow. So the only way to make them match is to make the smaller one match the big one by multiplying with coefficients. So now I have 3 yellows. My yellows are balanced. I have 8 blues on this side and only 2 blues on this side. So in order to make 2 into 8, it's 2 times 4 would be 8. So now I have 2 times 4, 8 blues and 8 blues. Looking at oxygen, I have 2 pinks on this side, and I have 3 times 2 pinks on this side. Okay, so I have 6 pinks here, and I have 4 times 1, 4 pinks there. In order to balance, we need to balance the total oxygens. Okay, so total, I have these 6 pinks plus those 4 pinks. I have 10 pinks on this side. I'm going to go ahead and just do that. I have 10 pinks on my product side, which means I have to have 10 pinks on my reactant side. Right now I have 2. So I have to make the small number match the big number by multiplying. So 2 times 5 equals 10. So now I have 5 times 2 pinks, 10 pinks. 3 times 2, 6 pinks here, 4 pinks there, so 10 pinks on each side. And when I have carbon dioxide and water as my products, or I have CHO reactions, those are always our combustions. Okay. You absolutely can use highlighters on all of our tests for chemistry. Sometimes this is really helpful, so if you need to color this for the rest of the year, that's just fine. We have no problem with the rainbow balancing method. Hope that helps.